So 4.1a, solving a quadratic equation by factoring. Now when we are solving quadratic equations, we could also call that finding the roots or finding the zeros. Okay, and the reason why we call it roots and zeros is because the graph of a quadratic, if you guys remember, is called a parabola. It looks like this. Okay, so solving for or finding the roots or zeros, it's all the same thing, means that we're finding the points, the 2 points, where the graph crosses the x-axis. So we call those the zeros because it's where y equals 0. Okay, so we have 3 steps to solving these things. Step 1, the first thing we want to do is make sure the equation is equal to 0. If it's not, we have to get it equal to 0. And we also want to make sure that the highest or the largest exponent has a positive coefficient. So we need to make sure that the largest exponent is positive. Okay, if it's not, we can move it to the other side to make it positive. Step 2, we just factor like normal using all of our different factoring techniques. And then step 3, we need to set each factor equal to 0 and solve. So we're actually going to have 2 or sometimes 3 different terms. And it's kind of like if we think of this. If I have x times y equals 0, in order to multiply 2 things and have them equal to 0, one of the 2 terms has to be 0, right? In order for x times y to be 0, either x has to equal 0 or y has to equal 0. Doesn't that make sense? So what we're doing in this situation is essentially the same thing. We have 2 different factors and we're equal to 0. They're being multiplied. So we take each of the 2 factors and set them equal to 0. Okay. So example 1. 16x squared minus 36 equals 0. We want to solve for x here. So when we're solving for a quadratic, the first thing we want to do is make sure the equation is equal to 0. Are we equal to 0? Yeah. And we want to make sure that the largest or highest exponent is positive. In this case, that would be x squared. And is x squared positive? Does it have a positive coefficient? Yeah, so we're good to go. So step 2 is to factor. So we want to factor this thing. What's the first thing we always look for when we're factoring? GCF. Do we have one? Yep, it's 4. So let's pull out a 4, and we're left with 4x squared minus 9 equals 0. Okay, and can we factor this thing? Yep. It's a difference of 2 squares. So we keep the 4 out, and we take the square root of 4x squared, which is 2x plus 3, 2x minus 3. All of that equals to 0. So that's step 2. We just factored the whole thing. You always want to make sure that you factor completely to make all of your solving easier. So then our last step is to set each factor equal to 0 and solve. So when I do this, I make a chart. I draw a line down the middle to keep my 2 factors separate, just so that I don't get all of my work confused. And I have 2 factors here, don't I? I have 2x plus 3 and 2x minus 3. Well, the 4 is just a coefficient on the outside. We don't have to worry about it, because 4 can't equal 0, right? So we don't have to worry about it. So in order to make this whole thing equal to 0, either 2x plus 3 has to be 0, or 2x minus 3 has to equal 0 in order to give us a true statement. Okay, so what are our possibilities for x? Well, we just solve these. We subtract 3 from both sides. 2x equals negative 3. Divide both sides by 2. So one possibility for x is x equals negative 3/2. Another possibility for x is we add 3 to both sides. 2x equals positive 3. Yeah. X equals positive 3/2. So those are our two choices. Those are our two roots. So how do I write my answer? X equals negative 3/2 and positive 3/2. So if we plug in either of these values for x into the original equation, we will get 0. Okay? This answer is telling me that on the graph for this equation, this quadratic equation, and you don't have to draw the graph, we're going to be doing this stuff later. But on the graph crosses the x-axis at negative 3/2 and at positive 3/2. So that's what we're doing. We're finding the places where the graph crosses the x-axis.
Where's the 4 go?
Okay, so example 2 is 45p squared plus 10p equals 0. We want to solve for x here. So the first thing that we're looking for is we want to make sure that the equation is equal to 0. Are we equal to 0? Yes. We also want to make sure that the largest exponent is positive. Is 45p squared positive? Yes, it is. So the next thing we want to do is factor. What's the first thing I'm always looking for when I factor? GCF. Is there GCF in here? 5p. So let's pull out a 5p. And we are left with 9p plus 2 equals 0. Okay, now this is a problem that is similar in looks to what our previous problem was, but we have something a little bit different here. What are my two factors?
Is it 5p and 9p?
Exactly. We have 5p and 9p plus 2. Both of those have variables in them. So we need to set each one equal to 0. So what I do is I draw like a mini T-chart just to keep my work separate. And I have 5p equals 0 and 9p plus 2 equals 0. Okay, so let's solve for the blue one. 5p equals 0. I divide both sides by 5, and I get p equals 0. And then let's solve the red one. I subtract both sides, 2 from both sides. 9p equals negative 2. Divide both sides by 9. So p equals negative 2/9. So my two answers in this case are going to be p equals 0 or negative 2/9. So those are the 2 points where the parabola of this function crosses the x-axis at 0 and at negative 2/9. Example number 3. M squared equals 8m. Okay, so this time we have m squared equals 8m. My first thing that I want to look for is that we're equal to 0. Is this one equal to 0? No, so we have to get it equal to 0. So what are we going to do? Let's subtract 8m from both sides. So then what would I have? I would have m squared minus 8m equals 0. And let's factor that. Do I have a GCF in here? M. So we factor out an m. So we get m minus 8 equals 0. You guys with me so far?
Wait, so how come you didn't use the 4 in the other one?
So we have two different factors here. What are my two different factors? M and M minus 8. So let's set each one equal to 0. Now this is really nice because we just get M equals 0. That's done. And then the second one, we have M minus 8 equals 0. So we add 8 to both sides, and we get M equals 8. Eventually, you're going to start being able to just do this in your head. So what is my answer? M equals 0, M equals 8. So this parabola crosses at M equals 0 and at M equals 8. Most times you're going to get two answers. Sometimes you might only get one, which would mean that the parabola only crosses the x-axis once, so that means it would be facing this way, which we will talk about. Okay, example number 4. X squared minus 3x equals 54.